Hi guys, today's notes are on 6.7a because we're actually going to have 2 days on 6.7. Today we're going to be modeling with exponential functions, and this means that we're writing equations given a word problem. Okay, modeling is writing or using equations, but for word problems. Okay, so the first thing you need to know is that an exponential function starts with y equals a times b to the x, right? Where a is the value you start with, and b is your base or your multiplier. So in this scenario, suppose that the number of bacteria per square millimeter in a culture in your biolab, so we're talking about number of bacteria, is increasing exponentially with time. So I have to tell you this in order for you to use this function right here. On Tuesday, there are 2,000 bacteria per square millimeter. On Thursday, the number has increased to 4,500. Okay, so we know a few pieces of information. We know on Tuesday, there's 2,000 bacteria. And then on Thursday, it's increased. So let's assume that Tuesday is day 1. Okay, so this will be starting, or day 0. So this will be our starting day. Thursday is 2 days later. So now we have 2 pieces of information. We have day 0 for Tuesday, which is 2,000. And then we have 2 days later, it has increased to 4,500. Now, this 2,000 is my A value. This other 2 and 4,500 is just an X value and a Y value. So what we're going to do is we're going to take our equation, y equals a times b to the x, and we're going to plug in all the values we are given. So 4,500 is y. We know our starting value is 2,000, but we don't know what our base is. Okay, but we do know that after 2 days is when our 4,500 bacteria happens. So notice now we have a single variable in our equation, and we can solve for b now. Okay, so we're going to divide by 2,000 on both sides. I'm going to use the math function on my calculator to reduce my fraction. Okay, it's 2.25, which is 9 over 4. So 9 over 4 equals to b squared. Okay. What I'm going to do now is take the square root of both sides, but instead of writing it as a square root, I'm going to write it as an exponent, but a fraction. Okay, this is going to help you later. Because what if it was like 3 days later or 5 days later, right? Our calculator can't do a 5th root. So if we use this, this will be a little bit easier for us to see. So I'm going to take my answer here, and I'm just going to keep going. I don't need to retype it. I'm going to hit to the power of, and then don't forget 1/2 goes in parentheses. So it'll be 1.5. I don't want decimals. I'm going to reduce it to 3/2. So let's write it in here. This is, you can retype it as 9 over 4 to the power of 1 over 2. Okay, any fraction always goes in parentheses. So I get 3 over 2 equal to b. Okay, well, what is it asking us to do? We have to write an equation. So then I can rewrite it as y equals 2,000 times 3 over 2 to the x power. And that's my equation that I'm going to use to continue on. Okay, and now it says predict the number of bacteria per square millimeter that will be in the culture Tuesday of next week. So the question is, how many days later? Right, because that's when I'm going to plug in for x. Well, if I started on Tuesday and I'm ending up on Tuesday, that'll be Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, 7 days. So I'm going to take my equation here, 3/2, and then I'm going to put in to the exponent of 7. Okay, 2,000. Instead of typing 3/2, I can go second and answer. And the reason I'm doing this is because later this number will get a lot crazier. And so this way I don't have to retype anything. Okay. Number of bacteria, we're going to round to the whole number. So that'll be 34,172 because it was 0.875, right? It was 34,172 point. That's poorly written, sorry. 171.875. So we're going to round up because of this number. Tell me the units always. So we're talking about bacteria here. Okay. So now, can you predict the time when the number of bacteria per square millimeter reaches 10,000? So if it reaches 10,000, then this is my y equals 10,000. Find x. So let's set up our equation. So we'll have 10,000 equals to 2,000 times 3/2 to the x power. Okay, so this is the same. We're going to solve, right? Divide by 2,000. We're trying to get x by itself. 10,000 divided by 2,000 is just 5. Okay, and this is a step I want you to be careful of. We're trying to get x by itself, so we need to get rid of this base of 3/2. So we're going to take log base 3/2 on both sides. That crosses out the right side, and we get x equals log of 3/2, log base 3/2 of 5, which we can rewrite as log 5 over log of 3/2. Okay, so let's do log 5, close parentheses, divided by log of 3/2. That'll be 3.96, which is approximately 4 seconds. Oh, 4 days, sorry. Okay, we'll do another one. Same thing though. So let's find the equation. We have 2 pieces of information, and assuming that it's very similar to the previous problem, we don't have our base. So assume the population is increasing with time, so the base is going to be bigger than 1 exponentially, so we can use our y equals a times b to the x power. 1970 census, so showed that the population was 203 million. So this is basically 0,203, right? Our starting value. 1980 showed that the population grew to 226 million. So 1980 is 10 years later, and then we have 226. So those are our 2 values. So A equals 203, and then we have 10,226 x and y. Okay. So in terms of the number of years, so whatever comes first when they're writing the sentence here, that's your y value. Oh, sorry, population is the first thing we're talking about, right? Expressing population in terms of. So population is my y, and my number of years is your x. Okay, so here's my equation. I'm going to have 226 equals 203 times b to the 10th power. It's a 10, sorry. And so we're solving the same way. Divide by 203. I don't think that can be reduced, but I'll check it. 226 divided by 203. Math. Nope. So we'll leave it. Equals b to the 10th. You guys see here we want the 10th root, but our calculator can't do square root with a 10. So I'm going to rewrite it as a fraction exponent for 10th root. And these 10s cancel out. So I have b equals 226 over 203 to the power of 1/10. Well, let's write our equation because we're not done. So our final equation is y equals, a is 203 million. And then I'm going to just rewrite b like this without rounding. So I don't actually need my calculator. Now, how do I put an x in after the fraction? Just do times x. Okay? So let's use this to predict the population for 2006. And we need to say 2006 minus 1970 to see how many years have passed, right? Equals to 36. So x is 36 now. So I have y equals 203, 226 over 203 to the power of 1/10 times 36. Okay, how do we write this on the calculator? You guys see that? The most important thing that you want to remember is this parentheses and then this parentheses. Okay? So if you type that in, to the power of 1 divided by 10 times 36, you'll get 298,000,000.745. Let's round to the nearest million, since that's what we're given here. So that's approximately 299 million. So now we're going to predict the year. So take a moment and just acknowledge that since y is millions, then the year is going to be x. So we're going to predict the year and solve for that. When it will reach 400, right? So if it will get 400 here for y. So we're going to set up 400 equals 203, 226 divided by 203 to the 1/10 power times x. Okay, so this is going to get a little bit messier in terms of what you have to write, but the steps are still the same. We want to keep this right now. So we're going to divide by 203. We have 400 divided by 203 equals 226 divided by 203 to the 1/10 power times x. And we want to get x by itself now. Well, this right here is just a number, right? So we want to get rid of that number. So that number is a decimal value. I'll show you. You guys see how that's my decimal value here? Okay, so it's 1.01, but I don't want to type that number because if I round halfway through, then my answer at the end is not going to be accurate. So what I want to do is I want to take a moment and just take the log of this entire thing. And I know it's going to be a pain. So log of 226 over 203 to the 1/10 power. I'm going to write it here. So let's write that. So this means now we have x equals log base 226 over 2, oh dang it, sorry. Got too close there. Okay, 226 over 203 to the 1/10 power of 400 divided by 203. Okay, so what does this look like? It's going to be one big fraction, right? Because you're going to have 2 logs now. And the argument goes on top, and the base goes on the bottom. So the argument is 400 over 203. And in the base, or the denominator, we're going to have 2, 2. We're going to need another parentheses, just so that you're aware. Okay, this is going to be a bit, you have to be really careful here. So I'm going to do a second parentheses of 226 over 203 to the power of 110. Now, if you are worried about these parentheses, what you can do is do the denominator first. You guys see how I did that? So now what I can do is I have my base, which is a whole number, or sorry, a decimal value. So that blue part is that number right there. Okay, so what I can do now is go log of 400 divided by 203, which is the numerator right here on top. It's perfect. Divided by log, and instead of worrying about typing that correctly, since I already have it in my calculator, I can go second minus, which is answer, and get my final answer quickly. Okay, please try that on your calculator. Maybe go backwards in time and see what you get. So the year that you're going to do it is 63 years later. And then we have to add that 1970, right? To get a total of 2033. So in the year 2033, the population in the United States will hit 400 million. This last problem is a you try, so if you want to pause your video here and try it, I'll post the answers, but I won't show all the steps and explain it because it's going to be exactly the same. Okay, so here's the answers, and I'm just going to show this last part. So if we do 40 to the 1/2 first, that gives me a decimal value. The calculator rounds, it looks like it rounds, but it didn't actually round. And then what we're going to do is take log of 1 divided by 30,000 divided by log, oops, I did log twice, of the answer. Okay. And so this will be minus 5.6 years, which means before 1865, right? Because that's when we started. Oops. Okay, so that means 5 years, or like we could do 6 years maybe. So that'll be about 1859, approximately, is when the first 2 rabbits were introduced. Okay, so this one grows like crazy, correct? So just keep in mind that that is actually what happened in Australia, and they now have an insane rabbit population.